Hi everybody, today we're going to do a tree diagram example and we're going to use the example of going on a beach vacation. A beachside hotel finds 20% of the guests are in-state and the rest are from out-of-state. 80% of in-state guests stay 1 to 2 nights and the remainder stay 3+ nights. 25% of out-of-state guests stay 1 to 2 nights, the remainder stay 3+ nights. We have a partially completed tree diagram below. We are going to finish it out so that we can answer some questions. As we put in our answers, we kind of want to leave a lot of decimal places, so we are going to put in 4 decimal places as needed. Our tree diagram starts by splitting into 2 choices. The type of guest is either in-state or out-of-state. Then for each type of guest, we look at the length of stay as being 1 to 2 days or 3+ days. So we already know that 20% of the guests are in-state, so what percent would be out-of-state? We can easily do 100 minus 20 is 80%. Now we can move on to the length of stay. We know 80% of in-state guests stay 1 to 2 nights, so what percent stay 3+ nights? 100 minus 80 gives me 20%. For the out-of-state guest, 25% stay 1 to 2 nights, so we just need to figure out what percent stay 3+ nights. 100 minus 25 gives me 75%. Now that our tree diagram is filled out, we can do a little bit more. When we multiply across through the branches of the tree, we get the probabilities for the and. So the first thing we'll get is the probability that a guest is from in-state and stays 1 to 2 nights. I'm going to multiply 0.2 times 0.8, which gives me 0.16. Then I could look at in-state and 3+ nights. That's 20% times 20%, which is 0.04. If I look at out-of-state and 1 to 2 nights, I do 80% times 25%. There's 20% of the guest. And then the last one, out-of-state and staying 3+ nights, 80% times 0.75 is 0.6. Now that we have this information, we can answer some questions. So our first question is, what is the probability a guest stays 1 to 2 nights? So we have 2 places that guests stay 1 to 2 nights, in-state guest and out-of-state guest. We need to add up the 1 to 2 nights in-state and the 1 to 2 nights out-of-state. That's 0.16 plus 0.20, which is 0.36. So 36% of our guests are only staying 1 to 2 nights. Then the probability a guest stays 3+ nights, well, we could go back to our in-state guest and our out-of-state guest and add up 0.4 plus 0.6, which gives us 0.64. Or we could say if 36% of the guests stay 1 to 2 nights, then the rest of them stay 3+ nights. That's 1 minus 0.36 is 0.64. So it's kind of however your mind thinks about it is how you would do the calculation. Or maybe you want to check your work that way. Now we can move on to some conditional probabilities. We'll start with if a guest stayed 1 to 2 nights, what's the probability the guest is visiting from in-state? To figure this out, we need to look at the probability that a guest was in-state and stayed 1 to 2 nights and divide by the probability that the guest stayed 1 to 2 nights. So in-state and 1 to 2 nights, we know that's 0.16. And we also know the probability of 1 to 2 nights is 0.36. If we divide 0.16 by 0.36, we get 0.444. Repeating, we'll call that 0.4444. Let's do one more. If a guest stayed 3+ days, what's the probability the guest is visiting from out of state? To find our probability, we look at the probability that a guest was out of state and stayed 3+ days, and then we divide by the probability of staying 3+ days. Out of state and 3+ days was 60% of our guests. 3+ days was 64% of the guests. If I divide 0.6 by 0.64, that's 0.9375. Hope that helps.